In this video, we're going to look at one last method for separating mixtures, and the method is called chromatography. Chromatography is actually a method for separating two or more substances that are soluble or that dissolve in a particular solvent. The common solvents that we use, they are water or ethanol, and the common mixtures that we use chromatography to separate are, for example, mixtures of mixtures of dyes in inks, or mixture of pigments in plant extract. So usually they have a distinctive color. So now we're going to look at the experimental setup for chromatography. So for chromatography, the first thing that we need is a piece of filter paper. And on the piece of filter paper, we're going to draw a line in pencil. This is known as our start line. And then on the start line, we're going to put a spot. Alright, we're going to put a spot of our mixture. And then what we're going to do next is to put the filter paper into a glass jar that's filled with a suitable solvent. For example, water. Another common solvent that we use is ethanol. Okay, and then to complete the setup, usually we will put a lid, a cover to the glass jar. So what we see here is the experimental setup for us to separate the mixture using chromatography. Now we're going to look at how chromatography works. So previously we have seen this setup, and once we put the filter paper into the glass jar containing the solvent, what is going to happen is that solvent is going to travel up the filter paper. Alright, and as the solvent travels up, it's going to reach your start point, and what's going to happen there is that it's going to dissolve the substances present in your mixture. And after dissolving, it's going to carry the substances up with it as it moves through the filter paper. Okay, so we will stop the experiment when the solvent reaches a certain level before the end of the filter paper. Now the highest point at which the solvent rise up to is known as the solvent front. Now a typical filter paper that we will obtain after separation of the mixture will look something like this. So you will see a few spots appearing at different parts of the filter paper. Now a filter paper that contains the separated spots, we call it a chromatogram. Okay, so why would there be different? Why would the mixture separate into different spots? This is due to the difference in solubility of each spot or each substance in the solvent. So as the solvent travels up the chromatogram, as the solvent travels up the filter paper, the spot or the substance that's more soluble in the solvent will actually move up faster. Why? Because the solvent has a stronger attraction on that substance. Conversely, a spot that's less soluble in the solvent will move up slower. Alright, why? Because the solvent has a weaker attraction on the spot or on the substance. Therefore, the spot that travels the furthest from the start line or moved up the highest on the chromatogram is the spot that is most soluble in the solvent. Whereas the spot that is nearest to the start line or move up the lowest on the chromatogram is the least soluble in the solvent. So once again, the principle behind the separation of the mixtures of the components in the mixture using chromatography is due to difference in solubility of each substance in the solvent. Having said that, if two substances have the same solubility in a particular solvent, then they cannot be separated using that solvent. Alright, so one change that you can make is to use a different solvent where the two substances have different solubilities in. Now that we have seen the experimental setup for chromatography, and then we have also looked at the how chromatography works. Now we'll look at what can we apply chromatography for. The first thing that we can apply chromatography for is to check for purity of a substance. So what we see here is a diagram that contains the chromatogram for the different colored inks. And based on the number of spots that we can see for each ink, we can therefore establish that the yellow ink is actually pure. Right? Why do we say that? Because after separation, we only see one spot. That means the yellow ink contains only one substance. Whereas for the other colored inks, we can see that after separation, there are two or more spots appearing for the ink. So what that tells us is that all the remaining inks are actually mixtures of different substances. The next thing that we can apply chromatography for is to identify the substances present in a mixture. For example, if we look at the chromatogram for the different color inks, we can tell that black ink actually contains one substance that is present in yellow ink. Similarly, green ink contains a substance that is present in yellow ink. How do I know that? Is by comparing the position of the spots. So the principle here is this: if a spot rises up to the same height on a chromatogram, it means that it is the same substance. Okay, I repeat, if a spot moves up to the same height on a chromatogram, it means that it is the same substance. So another inference that we can make is that black ink contains a substance that is also present in blue ink, that's also present in brown ink, and that's also present in green ink. Reason being, there's a spot that traveled to the same height for these four colored inks. Now let's imagine a scenario where I obtain another sample of a yellow ink. Okay, we are going to call it yellow 2. And I want to find out whether the substance in yellow 2 is the same as the substance in the original yellow ink. So what I can do is I can again perform a chromatography on yellow 2 ink and see whether I have the same spot as before. But there's a limitation over here. I must make sure that I stop the separation when the solvent front is at the same level as before. Alright, only then can I compare the height of the spots and then make an inference. Now, should I stop the separation before the solvent front reaches the original height? The question now is, would the spot still rise up to the same height as before? The answer is no. For example, if now I separate yellow 2, okay, this is also yellow 2, but my solvent front is only over here. What happens is that my spot may end up over here. Okay, so it is not as the same height as before. Can I still infer that they are actually the same substance? By simply looking at the height of the spot, we cannot. That is why we need to learn a new term. And the new term is known as RF value. RF stands for retention factor. So how do we obtain the RF value of a spot or of a substance? Is to take the distance between the start line and the spot divided by the distance between the start line and the solvent front. Now the definition that you see here is going to be different from what you see in a textbook. Most textbooks will tell you that RF value is the distance traveled by the spot divided by the distance traveled by the solvent. However, this definition is going to be highly misleading for certain types of questions. That is why I would recommend that you remember RF value to be the distance between the start line and the spot. So this is the start line, and the spot that we are looking at is here. Okay, divided by the distance between the start line and the solvent front. So this. Now for example, if the distance between the start line and the spot is 0.8 cm and the distance between the start line and the solvent front is 1 cm, so the RF value for this particular spot would be 0.8 divided by 1, which is simply 0.8. Now one thing to take note about RF value is that it has no units. In science we call it dimensionless. Okay, and for certain RF values, it's very tempting to leave them as fractions, but please do not do that. So for RF value, we always leave to decimals. For example, if there is a spot with an RF value of 0.5, we leave it as 0.5 and not half. Now, why is the computation of RF value important? It's because of this. Under the same chromatography conditions, meaning the same temperature, the same solvent is being used, the RF value of a spot is constant. So back to the problem that we had before, where in the second separation, the solvent front is actually lower than the one before. So the solvent did not rise up to the same level as before. So therefore we cannot compare the height of the spots, since they are definitely going to be different, even if it is the same spot. So in such a scenario, we can actually compare the RF value and they should be the same. Now in this example, we're going to look at how we can use RF value to determine whether we have the same substance in two different chromatograms. For the chromatogram on the left, we have determined the RF value of a spot of a substance to be 0.8. And the chromatogram on the right is obtained by separating the same substance, but this time we stopped the separation earlier. So therefore the solvent front is lower than the chromatogram on the left. So for example, let's say that the distance between the start point and the solvent front is now 0.8 cm. So if we were to measure the distance of the spot from the start line, we will obtain a value of around 0.64. So therefore we can go ahead and calculate the other RF value, and if you were to do it correctly, you will find that it also gives a value of 0.8. So by comparing the RF values, we can conclude that the two spots that we see in the different chromatograms are actually the same substance, even though they are at different positions on the chromatogram. Now a common type of question that we'll get involving RF value goes like this. So we are given the chromatogram on the left with the distances between the spot and the start line, and the distances between the solvent front and the start line shown in the question. So based on the distances given, we are supposed to calculate an RF value for the spot. which we can easily do so and find that it's actually 0.8. Then the second part of the question goes like this, that the separation was repeated on the same substance, but this time the distance traveled by the solvent, or the distance between the solvent front and the start line, is only 0.5. So we are asked to find the value of x, which is the distance of the spot from the start line. And how do we go about doing this is to recall that the RF value for the same substance under the same conditions should be the same. Meaning the RF value for the chromatogram on the right, for the spot on the chromatogram on the right, should also be 0.8 if it's the same substance. And how do we find the RF value for the chromatogram on the right? Is to take the distance traveled by the spot, or distance of the spot from the start line, which is x, divided by 0.5, which is the distance between the solvent front and the start line. So from there we can find that the value of x is actually 0.4 cm. Now with that, we have seen how we can actually apply chromatography for determining the purity of a substance, and more importantly for identifying the substances present in a mixture. Now let's go back to the experimental setup. Earlier we saw the experimental setup for chromatography. It looks pretty simple, but there are many points that we need to take note of. Now these are the points that we need to take note of when we are performing a chromatography. Okay, so firstly, the starting line must be drawn in pencil. It cannot be drawn with pen. Okay, first two questions, they look seemingly similar. However, the answer required for both are different. Okay, we'll take a look at it later. Next thing, the spot of the mixture must be above the solvent level. The spot of the mixture must be as small as possible, and usually when we perform a chromatography, the tank would be covered with a lid, or the glass jar will be covered with a lid. So why is it that we need to take note of these points? These are commonly tested in a chromatography question. So once again, question 1 and question 2 looks similar, but the answer required is different. So how are they different? Let's answer question 2 first. Why must the starting line not be drawn with pen? Why? Because pen, the marking of a pen consists of ink. And what happens if you have a start line that is made of ink is that when the solvent rises up, it will dissolve the ink in your start line, and then it will contaminate, it will ruin the chromatogram. So why is it that we can use a pencil then? Because pencil lead, alright, which is essentially graphite, is insoluble in the solvent. Right? Usually it is not soluble in water, it is not soluble in ethanol. So as the solvent passes through the start line, it's not going to dissolve your pencil lead, so it's not going to contaminate the chromatogram. Next, for question number 3, why must the spot be above the solvent level? If you imagine that the spot is below the solvent level, then the spot will simply dissolve into the solvent instead of being separated. Next, why must the spot be as small as possible? What happens if you have a very big spot is that the substances after separating will also be rather big, and one thing that we can get is that the spots may overlap, so we cannot really tell whether it's one spot, one big spot, or two spots that are merged together. And lastly, why must the tank be covered with a lid? Now if we are using ethanol as a solvent, ethanol has a rather low boiling point. Alright, so we say that it's volatile, meaning it will evaporate easily. So to prevent or minimize evaporation of the solvent, we will cover it with a lid. So here are the recommended answers for the questions that we have seen in the previous slide. As mentioned, this type of questions are commonly asked whenever you encounter chromatography, so please make the effort to go and memorize them. Now the last thing that we're going to look at for chromatography is the limitations of the method. Previously, we have seen that chromatography can be used to check for purity. For example, in this chromatogram we say that the yellow ink is pure. Now, in actual fact, chromatography is not ideal for checking of purity. Why? Because there may be situations where a spot is present but it is not colored. So since it is not colored, we cannot see it, and we may not be able to detect its presence. So even if we only see one colored spot, we cannot be 100% sure that the substance is pure. Now for colorless substances though, there is a way that we can overcome that limitation, which is we can apply what is called a locating agent. Okay, what a locating agent does is that it will turn the colorless spot, it will react with the substance in the colorless spot and change it to a colored spot. The second limitation of chromatography is that sometimes a substance in a spot may not be soluble in the solvent used. So as a result, even though there's a mixture present, but because the spot doesn't dissolve in the solvent, so it doesn't separate out, it doesn't move up with the solvent, so we may think that it is not present. Alright, so for substances that are insoluble in the solvent, it will not be separated. So with these two limitations, therefore, using chromatography as a method to check for purity is not 100% safe. In the next video, we're going to look at a better method for checking the purity of a substance.